Now we'll take a look at the other key question that's showing up in our first quiz on constant acceleration. And this is vertical motion. So let's take a look at the prompt for a second. And it says, describe a scene where an object is thrown vertically. Great, returns to the ground level. Okay, so we can assume that this object is thrown vertically and returns to the ground level. All right, great. So we're going to have to give it an initial velocity, otherwise it's not going to go upward. And we can keep this reasonable, and it doesn't have to be too tall or anything like that. And let's just scan and say if the object was thrown with twice as much initial velocity, would it go twice as high? Would it be in the air twice as long? Okay. All right, so for this question, let's go ahead and come up with a scenario. So I'm going to go off to my document camera and we'll take a look at a quick, I'm just going to brighten this up a little bit. Yay, so I could draw a stick figure throwing a ball or something like that, but if we, all right, what's this going to look like? So stick figure throwing a ball like this, and we'll give it some initial velocity, whoop, like that. So let's assume that it starts from ground level. So its initial height is equal to 0. And its initial velocity in the y direction is equal to, let's pick a number like, say, 20 meters per second. And ball's going to go up, and ball's going to come back down again. And during the course of its flight, there's actually, there's quite a bit of stuff going on here. So as the ball's on its way up, the velocity will be decreasing. So even though the velocity is directed upward, it's got gravity, which is pointed downward, because the acceleration due to gravity is caused by gravity. And, we really talk later on about acceleration being caused by forces. So if the force, the pull of gravity is downward, so obviously the acceleration is always downward, which is a bit of a misconception because some people think that although the velocity will be 0 at the highest point, that the acceleration is still downward. The misconception is a lot of people would say the acceleration is 0 at the highest point, but it's really important to recognize how the velocity is how fast and what direction, but the acceleration is how that's changing. So it's totally legit to change, have something decrease, become 0, and then actually go in the negative direction, so that later the velocity is going to be downward and the acceleration is downward. And there are a couple of things in some of the notes I've posted about when these two oppose each other, the object slows down. When they are pointing in the same direction, they speed up. And right up here at the highest point, when the velocity is 0 and the acceleration is not, that means that we're expecting a change in direction. So on the way up, it's slowing. And on the way down, it's speeding up. And at the highest point, it's changing direction. And those are the 3 ways that you can accelerate. Slowing down, changing direction, or speeding up. And that's it, really. Okay, well, let's work through an example and see how this sugars off. I think it's really important, too, to remember that given all this information, we can actually break this up into 3 different parts. And it's worthwhile just thinking about those parts. So let's break this down into on the way up, and then on the way down. Good. Let's list our variables. Initial height, final height, initial velocity in the y direction, final velocity in the y direction. In gravity, the acceleration is equal to negative g, where 1g is equal to 9.8 meters per second squared. And then we have time. And then if we do on the way down, we'll list the similar variables. Get my hand out of the way. Just a second, and time. And now let's go ahead and now transpose what we know. So on the way up, we said the initial height is equal to 0. I'll write meters down there for units, but I don't know. Does 0 really have units? I don't think so. The highest point, we don't know what that is. The initial velocity in the y direction is equal to 20 meters per second. And then the final velocity on the way up is equal to 0. Now, you notice if we try to combine up on the way up and on the way down into just one long piece, then the final height would be equal to 0, and so would the initial be 0. But we won't know what this is, the maximum height, because by going up and back down again, we're not taking a look, we're just looking at the endpoints. We're not looking at what happens in between. So that's why it was a smart move to break this up into on the way up and on the way down. All right, terrific. Let's try and do the same thing on the way down. We assume that we don't know what the initial height is, but the final height would be equal to 0. So there's some kind of symmetry happening here. And the initial velocity is 0 meters per second. And the final velocity we don't know. Okay, and we want to see if we can find out what's going on. Now, one of the things we want to know is how high does it go? So that's this question right here. This is going to be what we would call the maximum height. One day I'm going to write a spy novel, and the lead character is going to be Max Height. I just think it's a great name. Okay. I mean, I was thinking about changing my last name to Height, but last name is Chase too, which has a lot of physics applications. So, all right. Anyway, let's get serious now. How do we solve this? Now, you remember we have several kinematic equations to choose from, but what we need here is we need something that doesn't have time. So what we're asked to do really is we want to find our max height without knowing what the variable for time is. And so a good choice for that is going to be this. Final velocity squared equals initial velocity squared. And now minus 2 times g times y minus y0. You remember there's a list of those 4 kinematic equations, so I'm just trying to find the one that's got height without time. Okay, now I can throw some numbers in here. So the final velocity is 0. The initial speed is 20, and that's going to be squared. 2 times 9.8 is going to be minus 19.6. The initial height is 0, and so now I'm just looking for y, and that's totally solvable. That's a good way to get started for that question. Later, you're asked, okay, if you double the velocity, what's going to happen to the time of flight? So we didn't do time, right? But once we know what y is, we can pick another kinematic equation and get time to get to the highest point. And then the time on the way down is going to be the same thing, so we can just double that. But then you'll go ahead and solve this problem again by doubling the velocity and seeing what you get for a time. All right, well, good luck.